Hey guys, welcome back to my channel. I hope you are all doing great. If you are new to my channel, don't forget to subscribe and don't forget to tap the bell icon so that you won't miss any updates from my end. Without further ado, let's get into today's video. Hello everyone. Today we are going to complete one more problem. This is medium level problem from LeetCode. Minimum rounds to complete all tasks. Let's try to understand the problem statement. We'll be given one integer array task where each element represents the difficulty level of task. In each round, you can complete either 2 or 3 tasks of the same difficulty level. Okay, we need to return the minimum rounds required to complete all tasks. If there is no such possibility, we need to return the -1. Let's try to look at this example. Here, these are the tasks, and there are few tasks of same difficulty level. So 2, 2, 2, 3, 3, followed by all fours. So how we can complete this all tasks? If we carefully observe, in first round we can complete 3 tasks of same difficulty level 2. That means this 2, 2, 2. These 3 can be completed in one round. In second round we can complete this 2 of difficulty level 3. In third round we can complete 4. Okay, 3 tasks of difficulty level 4, I mean to say. Since we can complete either 2 or 3, we can complete maximum 3 here. Then rest 2. The 2 we can complete in another round. So if we carefully observe, we need a minimum 4 rounds to complete this all task. That's all the problem statement. I hope you understood. Let's jump into the board to see how we can solve this problem. This is our input array: 2, 2, 3, 3, 2, 4, 4, 4, 4, 4. Okay, looking at the problem, what is the first thought for us? We need to count the number of occurrences of each difficulty level, right? So for that, I'm going with the hash map. So the pair is going to be 2, 3, where 2 is the difficulty level of a task and 3 is the number of times it occurred. Then 3, 2, then 4, 5. Okay, this is the first step we need to do. Then what we are really need to worry about is the occurrences, right? We no need to worry about this. So I'm going to have a res variable which is used to what I can say track the number of rounds taking. Now what I'm going to do here is I'm going to iterate through these values, and whenever occurrence is 1, okay, assume I'm taking a val which represents the occurrence. If val equal to 1, then we can simply return -1 because we need minimum 2 to complete a round. Okay, 2 or 3. If there is a 1, we cannot complete that round. So we can simply return -1. Otherwise, what we can do is whatever the value here we are getting, we can simply divide it by 3. Okay, whatever result we are getting, we can add that to here. Okay, here 3 is nothing but val. Okay, and if this particular value, in this case this 2 and 5, is not divisible by 3, right? So val mod 3 not equal to 0. Since this condition satisfies, just increment this by 1, res plus plus. Only these two equations are sufficient. How these two are going to help us? Let's try to debug this only directly. So here 3, right? 3 divided by 3, what it returns me? It returns me 1. So initially res is 0, then res is going to be now 1. Done. Then is this condition going to be true? While mod 3 not equal to 0? No. This is going to be false, right? Because 3 is divisible by 3. Then I come here 2. 2 divided by 3 which returns me 0. Okay. Then my res still remains 1. But if you look at this, val mod 3 not equal 0, is this condition going to be true? Yes, 2 cannot be divisible by 3. In this case, I am simply incrementing my res. That means res will become 2. Then it will going to have 5. 5 mod 3, which returns me 1. Then my res is going to be 3. Is 5 mod 3 not equal to 0? Yes, then res is going to be 4. So I'm done with iterating through all the entries of map. then I can return whatever I left over as a result here. 4 I can simply return. So this is how we can solve this problem. I hope you understood the institution behind the problem. Let's try to see time and space complexities. The time complexity is going to be big O of n because we are going to iterate through the each element initially and we fill the hash map and then we're going to iterate through the hash map to do this calculation. Then time complexity is big O of n. Space complexity also big O of n, assuming this all elements are constant while we're trying to fill this hash map, then it is going to take big O of n. That's all. Let's jump into the coding part. Here I'm going to retrieve my last submitted code. So if you carefully observe what I did, I took a min count which is going to track the minimum number of rounds required to complete all tasks, and a hash map I took, and I iterated through all the tasks and I filled my hash map. Then I really worried about iterating through only values. Whenever I see any occurrence, okay, any value equal to 1, there and then I'm simply returning -1 because I no need to worry about the rest of the other things. If that is not the case, I'm dividing that occurrence divided by 3. I'm doing the division here. Whatever value I get, I will add to min count. If that value is not divisible by 3, I'm simply incrementing this, then min count, returning min count. That's all. So you can think in this direction. So assume there is a difficulty level of 5 which occurs 7 times. Okay, I quickly close this. So 3, 4. So how many rounds we require to complete this one? Looking at this, we need first we need to go with the 3, then 2, then 2, right? So minimum 3 rounds we require to complete this all. So according to these equations, how it is going to be? First, how many times it occurs? 7. 7 divided by 3, which returns me 2. So my res is 2. Since 7 more 3 not equals 0, then I am going to increment this by 3. And you see, our equation justified this. So that's the reason this logic. Let's submit. Yeah, it got submitted successfully, and I hope you learned something new today. Please, please like and subscribe to my channel, and don't forget to tap the bell icon so that you won't miss any updates from mine. Till the next video, bye bye.